Section 9.1, linear inequalities in two variables. So grade 11s, this should be a review from Foundations of Math 20, graphing linear inequalities. But don't worry, you don't need colored pencils for this, which is nice. Not yet. Okay, recall that to graph a linear equation, you can use one of two methods. Either you solve for y or you use the intercepts. So I do want you to do some old school graphing here, not just relying on the iPads, because it's good to know how to graph a line. So first of all, you could use isolate for y, and you put it in y equals mx plus b. B is your y-intercept, so you go to 0, b, and then you use slope, so up and over however many the slope is, to find your second point and draw a line. You can also use intercepts. You determine the x-intercept by letting y equal 0, and determine the y-intercept by letting x equal 0. And this is going to give you 2 points, and you can do a line. Okay, so now to graph and solve a linear inequality, we need to isolate y. We graph it using either method 1 or method 2. We determine whether the boundary is a solid or a dashed. So solid means that we have an equal sign. So we have less than or equal to, or greater than or equal to. It's dashed if there's no equal to's. Okay, select a test point above or below, and remember we always try to do the test point that is 0, 0 if we can, and we test it. If it's true, we shade it. If it's not true, we shade the other region. So a couple good examples they have here. So if you're stuck, come back to this page. Y is greater than x plus 1. So we have a dashed line because there's no equal to. And what they did is they said, well, let's test 0, 0. Is that in the point? If I put 0 here and 0 there, is 0 greater than 1? No. So they did the other region. And so how they graphed y, they looked at the line y equals x plus 1 to do the boundary, and they said, well, the y-intercept is going to be at 0 and 1. There's the y-intercept, and then they used the slope. The slope was 1 over 1, so they went up 1 over 1, up 1 over 1. That's how they graphed that line. Okay. Let's do, they're all pretty similar. Okay, solid line or dotted line, and which region to do. There are an infinite number of solutions to a linear inequality. It's the entire shaded region. Solving a linear inequality means determining the solution region in the Cartesian plane, rather than determining a point or points on the line. So that's what we're looking for at the end here, is a region. Okay? Graph and label the linear inequality 4x minus 3y is less than negative 12 for the set of real numbers. Okay, I'm going to isolate y. I'm going to treat this like an equal sign for a second just to do my work. I said I was going to, and then I didn't even do it. Is equal to negative 12. I'm going to get y by itself. Minus 3y is equal to negative 12 minus 4x. I'm going to divide everything by negative 3. So dividing by 3, dividing by negative 3. Okay, I'm going to use intercepts this time. So to get my 2 points, first of all, I'm going to let y be 0. And this is going to give me an intercept. And times by 3. So I get negative 12 equals 4x. There we go. I get x is equal to negative 3. So when x equals negative 3, y equals 0. So there's 1 point right there. My other point I am going to get, I'm going to let my x equals 0. And I could have done it from this original equation too. So 4 times 0 minus 3y equals negative 12. Minus 3y equals negative 12. Y is equal to 4. So when x equals 0, y equals 4. I have 2 points. Okay, so I could go and draw that line, but let's just see here. It looks like I'm doing a dashed line. So I can put a dashed line through there because there's no equal to. Now what I'm doing is I'm doing my test region. I am testing to see if I'm talking about the region above or below. And I'm going to use the test point 0, 0, and I'm going to sub it into my original equation to see if that's true. If it's true, I'm going to color below. If it's not true, I'm going to color above. So 4 times 0 minus 3 times 0 is less than negative 12. Is 0 less than negative 12? No, it's more than. So it's not this region. It is the region above. Okay? Let's try another example. Graph and label the linear inequality for the set of real numbers. Okay, so now what I'm going to do is I'm going to use slope-intercept form. So I'm going to treat it like a line just to find out my boundary. I'm getting y by itself. Minus 3y is equal to 15 minus 2x. Y is equal to negative 5 plus 2/3 x. Okay, so y equals mx plus b, so my slope is 2/3. My b is negative 5, so that means my y-intercept is at negative 5. I put a dot there. And now I use slope. So I go up 2 and over 3, up 2 and over 3. And that's my line. It looks like I'm going to have a solid line because it's less than or equals to, and I have to decide the region. I'm going to test 0, 0 to see if it's above or below. Well, is 2 times 0 minus 3 times 0 greater than or equal to 15? Is 0 greater than or equal to 15? It is not. So I am talking about the region below. Okay? One last question to try. A sports equipment manufacturer makes footballs and soccer balls. One football requires 4 minutes on the cutting machine, while one soccer ball requires only 3 minutes on the machine. So let's do F and S. So it looks like 4F and 3S. Determine an inequality that represents the situation. Draw a graph of the inequality to show that the number of each type of ball that could be made in 30 minutes or less. So 4s plus 3s needs to be less than or equal to 30. Okay, so there's not one answer. There's lots of different numbers of balls you could make less than 30 minutes. You could make all footballs. You could make all soccer balls. You could do a number of them. So from last year, we would say this is discrete, right? Because you can't make half a ball. Or maybe you wouldn't say it's discrete. Maybe you'd say, yeah, I want to know that I'm half done a football after 30 minutes. Okay, we're going to assume we haven't talked a lot about discrete in this section, so we're going to assume it's continuous for now. Okay, so my favorite is doing slope-intercept form. We have to decide which is like x or f. Let's do this one as f and this one as s, x and y. Or we could have done x and y and x and y. It doesn't matter. Okay, I'm going to change mine to x and y's actually, because my axis is giving to me an x and y. Okay, so I'm going to solve for y. Okay, dividing by 3, I get 10 minus 4/3 x. Okay, so I start at my y-intercept, which is 10. And my slope is I go down 4 and over 3. 1, 2, 3, 4, over 3. 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Okay, so I have my points. It looks like I'm going to do a solid line. So I draw a solid line, and I'm going to do the test point of 0, 0, because that's the easiest. Well, 4 times 0 plus 3 times 0, is that less than or equal to 30? Is 0 less than or equal to 30? It sure is. So I'm talking about all this region below here. Okay, but you would have to be a little smart and think, am I really talking about the whole thing? Can I make negative balls? Probably not. So I'm probably really only talking about here. So do be aware in the context of the problem, you might have to fix that up. Okay, so I do not want you to use iPads for this. I want you to do some old-fashioned graphing to get used to the two ways of graphing.